Why, thank you. Zoom was like recording in progress. Way to announce yourself, lady. So they need a better Zoom voice. Like even Siri sound nicer than that. So grumpy Zoom voice. All right. Questions on the red one. Ooh, New Zealand. That sounds fun. All right.
What can I do?
I don't know. I have no idea. I was just reading the chat. I was like, what? I just said New Zealand sounds fun. Oh, there you go. There you go. The voiceover, you would sound better than the Zoom person that was like recording in progress. Like it was very angry. And saying that you would have the better voice. I agree. All right. Let's look at this next one. Guys, same thing. Still going to distribute. Anything next to a parenthesis, you distribute. That -2 there, not next to a parenthesis. Please don't distribute it. Okay, so we got 4 times x is 4x. And then 4 times 3 is 12. And then -2 is equal to 2x plus 10. Okay, again, combine like terms, only the things that are the same on the same side. So in this case, it's 12 minus 2. And 12 minus 2 is 10. And then we have 2x plus 10. And then again, I do just like to keep my variables positive. That's just my preference. So I tend to subtract um, the smaller number from the bigger number, or I tend to add any negatives just to try to keep variables positive. It's not always possible, but it's just my preference. So I'm going to subtract the 2x there. And we got 2x plus 10 is equal to 10. And then subtract the 10. And 10 minus 10 is 0. And we're going to divide by 2 because 2 times x and 0 divided by 2 is 0. Now, what's interesting is 0 is a number. But every time we tend to get 0, a lot of students put no solutions or infinitely many solutions. Guys, if you get x equals 0, 0 is a number. You can have 0 of something, right? Like when you were little, your parents were probably like, I have 0 nerves left because you have gotten on all of them. This is a joke, people. Didum dishum. None of us would get on our parents' nerves. We're the apple of their eyes. Okay. Questions on the orange problem. That's right. I did do 4x minus 2x. 4x minus 2x is 2x. Anything else? Ah, no worries. That happens more than you think. All right, let's look at this third one. All right. More distributing, more the combining of the like terms and so on. So distribute 2 times 3x, we have 6x. 2 times 1 is 2 minus 4, and we got 6x plus 5. All right, combine your like terms. 2 minus 4 is negative 2. So you have 6x minus 2 is equal to 6x plus 5. And again, in this case, we're going to subtract the 6x. And 6x minus 6x is 0 x's, so I get negative 2. And then the same thing over here, 6x minus 6x is 0 x's, so I get a 5. Well, does negative 2 equal 5? Not the last I checked, right? So this is a special case, right? Negative 2 does not equal negative 5. So this is a special case that no matter what, there is no solutions to this problem. Okay? You can also write it, you can write it as no solutions. You can write it as a set of empty brackets. Or you can write it as an O with a slash through it. This particular O with a slash is used in what is called interval notation, which, by the way, we will use this entire term. Okay? Questions on the blue one? Okay. Move to the right. So you have 5. We don't have 5 nothing. 5 times 2, Karen, is 10. Okay, thank you. And then 5 times negative 1 is negative 5, and then plus 3. And then we have 10x minus 2. Again, we're going to combine the like terms. And you have 10x, negative 5 plus 3 is negative 2, is equal to 10x minus 2. Okay. All right. Subtract the 10x. And 10x minus 10x is nothing, so we got negative 2. Same over here on the right, 10x minus 10x, and we're left with negative 2. Negative 2 does equal negative 2. It absolutely does. Negative 2 can only equal itself. So this is a special case called infinitely many solutions. And that's a lot to write. Okay? So instead of writing infinitely many solutions, we are going to give the answer in interval notation, which is all real numbers, which is negative infinity to positive infinity. And again, that is called interval notation.
Do you want us to write it like that, or could we abbreviate
Yes,
say IMS?
interval notation. All of our answers are going to be written in interval notation.
Like we can write the interval notation, not the words. You don't need the actual words. We can just do the infinity.
Correct. Yeah, I'm just labeling the type of notation that it is. You don't need to write the words interval notation. I'm just letting you know that that's how you write this particular solution in interval notation, because interval notation solutions is what we are going to be using from here on out. We don't need to write interval notation at all. You don't need to write that word at all or abbreviate interval notation. I'm just labeling it. Oh, that's not green. Just label. Interval notation is just a label. We are going to write our answers in interval notation though, for the items that require it, such as the things on the second page. Okay, what other questions do you have on the green one? All right,
Just wondering, what is this type of question called?
this is the first four we did. These are called linear equations.
Hmm.
And now we're going to get into rational equations.
All right, thank you.
You are welcome. All right. Okay, these next set, these are rational equations, the next like 8 of them, okay, because they require a little bit more finesse, I guess, a little bit more practice. Okay, because we normally don't work with these. Normally we work with the first 4 with linear equations and things like that. We cover those a lot in like when we were in high school in Algebra 1 and Geometry and Algebra 2 and all that. Very rarely do we see very many rational equations until later in Algebra 2 and pre-cal, trig, things like that. Okay, so in this particular case, we know it's rational because it has fractions with variables in the denominator, right? A linear equation can have fractions, but if there's a variable in the denominator, it's not linear. So the 12 divided by x, that makes it rational. The 4 divided by x makes it rational, not linear. Okay? So what do we know about fractions? What do we know about fractions that can't happen? So that's what we're concerned about. What cannot happen with fractions?
They can't
What?
be proper.
Nope, they can be improper. There's something that can't happen with a fraction, though.
I
Well,
forgot
you
whether
can't
or
be
not.
dividing by 0.
That's
Yeah,
right.
I was
Okay.
gonna say
You were going to say that too? There you go. The denominators of fractions cannot equal 0. Okay. So that right there with rational functions is the big thing we have to remember, that the denominators of fractions cannot equal 0. Okay. And if I get, so for this particular one, right, if I go to check my problem and my answer is 0 and I go to check it and my denominator comes out as 0, then I don't have any solutions at all. Okay. So first things first, raise your hand if you like fractions and don't lie. Yeah, put your hands down. I know you're lying. I can't see anybody, but I just assume if somebody raised their hand, they're lying. Ain't nobody like fractions. I do because I'm a weirdo. And right, that's why I do math, because weirdos. All right, so let's get rid of the fraction. We're going to get rid of the fraction by multiplying everything by that denominator of x. Okay, so then you have 8 times x, which is 8x. Negative 12 over x times x is negative 12, because boom, boom, that goes away, right? Equals 3 times x, which is 3x. And then 4 over x times x, boom, that goes away, plus 4. Okay, now the way I rewrote that one's a whole heck of a lot less scary than the original problem, because I got rid of the fractions. Okay, so again, I start with my variables. I like my variables positive, so I'm going to go ahead and subtract 3x. And then we get 5x minus 12 is equal to 4. And then I'm going to add the 12. And 5x is equal to 16. I'm going to divide by 5. And x, you can, this one, you can leave it as a fraction or you can use the decimal. It doesn't matter. The only time decimals are dangerous is if you round them. 3.2 is not roundable, so there you go. Now, the denominators of fractions cannot equal 0. If I put 3.2 underneath the 12, is that 0? Hello? Is this thing on?
No, it's not.
No, it's not,
No.
right? So the only thing that would have made this not have an answer, or if the answer to be no solutions, would be if I actually got the answer of 0. Okay? So because the denominator of these fractions cannot equal 0. Okay? And I apologize as I don't know what you mean by I can't see the bottom.
I think she's talking about the bottom, the scroll down a little on the screen.
Oh, as I say on mine it's the whole problem showing, so that's why I was confused. I apologize.
It says or, and but you can't. Okay. Yeah.
Better? Did I get it? I'm trying.
She said yeah.
Okay. All right. Same thing with the one on the right. We don't want fractions because fractions are ugly and scary. Nobody likes them. So we're going to multiply everything by x because that's the denominator. And same thing, 6 times x, 6x, negative 10, because negative 10 over x times x is just negative 10. 2 times x, 2x. And then 7 over x times x is just 7. Okay, again, the denominator of these fractions, they can't be 0. So if I get 0 as an answer, then 0 is not an answer. It'd be no solutions. So I have to get any other number answer except 0 in this case because denominators of fractions cannot equal 0. Okay, so I'm going to subtract the 2x. Okay, we're going to add 10. So you get 4x is equal to 17. Then I'm going to divide by 4. And I don't really like decimals, so I'm actually just going to leave this as a fraction. Not a decimal fan. If you write it as a decimal, that's fine. That's up to you. But if I look up, is 17 over 4, is that going to make my denominator 0? No, it's not. Thank you for participating. You're welcome.
I was trying to unmute.
That's okay. It's not just you. It's that there are 20 folks in here. There are 20 folks that can say no.
Oh,
No. All right. Questions on the purple one. Okay. Try the third one there, the 6 over x minus 3 over x problem, etc. Try that one. I'm being harassed by my cat. She's like, so you're just kind of sitting there. Want to pet me? All right, time check. Would anybody like more time?
Yes, just one more minute.
Yep, no worries.
Okay, I'm good.
Okay, anybody else? Okay, I'm going to do the same thing that I did on the top two. I'm going to get rid of these fractions. So I'm going to multiply through by that denominator. Again, that denominator cannot be 0, right? Because none of those fractions can have 0 in the bottom. So 6 over x times x is 6. 3 over x times x is -3. And then 3 over x times x is +3. So 6 minus 3 is 3. Well, I'll be doggone. 3 does equal 3 the last time I checked. This is infinitely many solutions. Now, I understand that if you got infinitely many solutions, you are like 90% right. It's infinitely many solutions, but x cannot be what value?
0.
0. So it's infinitely many solutions, but x cannot equal 0. So I told you we needed to write our answers in interval notation. So to write our answer in interval notation, well, infinitely many solutions in interval notation is -infinity to +infinity. We showed that up there in the green problem. So we're going to write this as -infinity to +infinity, but we're going to skip 0. And to skip 0 on -infinity there, you put comma 0 parenthesis. And on the +infinity, you put 0 comma +infinity. And then you put what is called a union symbol in between them. So that's how you would write the answer, infinitely many solutions, but x cannot equal 0. That's how you write that in interval notation. Again, this is how you write it in interval notation. And we are going to do more with interval notation, but this is just kind of a little bit of an intro to it. Okay? Questions on the Brown problem?
How'd you get rid of the 6 again? Sorry.
6 minus 3. I just did the subtraction. 6 minus 3 is 3.
Oh yeah, thank you.
Yeah, no worries. All right.
So just to be
Yes.
clear, linear you can have 0 as the answer, and rational no, you can't.
It's not that you can't have 0 as an answer. You can't have a denominator that is made 0 by any value.
Okay.
And since the only value in the first 3 problems we did, we only just have a singular x, so the only value that would fit that requirement in this particular situation is 0. And we're going to see that shift here in the next handful of problems. Because notice the denominator for the one next to the Brown problem is different than the denominator of the Brown problem. Okay, so good segue, good question into a segue here. All right, so what we have here is we have the x plus 1 binomial with 2 on top, and then we have the x minus 3 binomial with the 1 on top, and then we have the x squared minus 2x minus 3 binomial with the 5 on top. Okay, now I am going to offer you a little bitty baby tiny hint that will save you a little bit of stress, hopefully. Okay, so whenever you have 2 binomials and a trinomial, the trinomial will factor into the 2 binomials. And you guys are like, what? So work with me here.
I even said it out loud to myself as you said it.
When you have 2 binomials and 1 trinomial, okay? And I will highlight what a binomial and a trinomial is here in just a second, but I'm going to write down what I just said. The trinomial will factor into the 2 binomials. Smiley face. Okay. And let me, okay. 2 binomials are these 2 right here. Okay. 1 trinomial is this guy right here. Okay. So what that means for us is that that is 2 over x plus 1 plus 1 over x minus 3 is equal to 5 over x plus 1 x minus 3. So that way, right, all the factoring that we just did before we started doing this, you don't have to do that shenanigans. I gave you a shortcut. Hooray. Thanks, you're the best. I know, I know.
I think the shortcut was just so good. It was kind of like stunning. It's confusing that it's that easy.
Overwhelming.
You know what I mean? Yeah.
Don't worry, I'm my own hype man. It's fine.
You have to be.
Sometimes, yes. Okay. So the reason you would do that is because on these first three problems, right, that just had x as the denominator, right? We just have x as the denominator. We knew that the denominator could not be 0. We set it up here. You guys even said it. The denominators of fractions cannot equal 0. Well, when x is just the denominator, the only answer we have to worry about is 0, right? Because 0 is the only thing that's going to make a singular x 0. And so now, in this particular case, I have x plus 1 as the denominator and x minus 3 is the denominator. And then over here with the 5, I have x plus 1 and x minus 3. Thankfully, they are the same, right? It's both an x plus 1 and an x minus 3. Okay? So how you figure out what answers cannot work is by setting the denominators equal to 0. So in this particular case, x plus 1 cannot equal 0. So x cannot equal -1. So if I get -1 as my answer when I solve this, it's no good. It's no solutions. Okay? And then I've got x minus 3 also cannot equal 0. So if I get x is equal to 3, then again, I can't do this. Okay, so x cannot, oops, I'm sorry, I forgot my cannot symbol. There we go. Okay, so if I get -1 as an answer, or if I get +3 as an answer, then my whole answer is just thrown out the window and it's no solutions. Okay, but if I get anything else besides those two numbers, then I'm good to go. Okay? So let's see how we do. Again, we don't like fractions, and don't lie to me and tell me you do. We're going to multiply the denominators by the entire x plus 1 and x minus 3. So I am going to write this out. It is going to look a little weird. I am going to write it out though so I can show my work and show you my thought process instead of doing mental math. Okay, so I've got 2 over x plus 1, and I'm going to multiply that by x plus 1 and x minus 3. And then plus 1 over x minus 3. And I'm going to multiply that by x plus 1 and x minus 3. And then equals 5. And I even did the skinny pin on this last time too. Hold on a minute. See if I can scooch this over. And then we got 5. I'm going to have to write this really small. X plus 1 and x minus 3 times x plus 1 and x minus 3. There we go. I got it all in there. Hooray. Okay. Now, on that first fraction, the 2 over x plus 1, what cancels out here?
X plus 1. Yeah.
X plus 1. Boom, boom. So I'm left with x minus 3, right? So 2 times x minus 3. On the 1 over x minus 3, what cancels out?
X minus 3.
X minus
X minus
3.
3, yeah. And I'm left with the x plus 1. So it's 1 times x plus 1. On the 5, what cancels out with the x plus 1 and the x minus 3?
X plus
Plus
1.
1, X minus 3. Oh.
Yeah, both of the things, all the things, right? So that's why we multiplied by that big ugliness. So there we go. So guys, now we have this normal looking problem, right? So we're going to distribute. So this is 2x minus 6. And then 1 times all of that is just 1x and then plus 1. And then equals 5. And then combine like terms, 2x plus x is 3x. -6 plus 1 is -5. We're going to add 5. And then we have 3x is equal to 10. And we're divide by 3. X is equal to 10 over 3. Now, this is not one of those where you can use a decimal because this is a repeating decimal. It has to stay as that fraction. Okay, so is 10 over 3 -1 or is 10 over 3 3? Say
No.
no. Yay, there we go. No, it's not. Okay, so the only answers we could not get were -1 and +3, and we didn't get either of those answers. So there you go. That is your solution. Hooray. Questions on the pink problem?
Hey, you mind going back up just for a quick second?
Not at all. How far up?
You're all good right there. Thank you.
Okay.
All right, thank you.
Yeah, no worries. All right. What other questions we got on the pink problem? Right. I'm going to do this one on the right. Okay. Boop, 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 doo. All right. So this x squared minus 4. I don't have two binomials. Unfortunately, I just have the one. But this is called a difference of squares. That thing is called a difference of squares. And difference of squares are actually really easy to factor. You just take the square root of 4. And the square root of 4 is 2 and -2. It's plus or minus 2. Okay? And a difference of squares factors into the square root of the number. Okay? Okay, so it factors in the square root of the number. So in this particular instance, I have 2 over x minus 2. And don't worry, I'll give you guys time to write that down. And then this actually becomes 4x over the square root of 4 is plus or minus 2, x plus 2, and x minus 2. Because the square root of 4 is 2, or the square root of 4 is -2. So it factors into one of each.
So when you say the square root of the number, it's whatever number's in the problem with it.
Yeah. So like it's x squared minus 4. So in this case, it would be the square root of 4 is plus or minus 2. And then down here, my problem, I got my plus or minus 2.
So if it was x squared minus 9, it would be the square root of 9.
Yep. And so it'd be plus or minus 3.
So would we write that in interval notation, or is that the way you'd write it up there with the little arrow?
I was just showing you what the square root of 4 was.
Yeah. Okay.
All right. So same thing that we did up here with the pink problem. I got to figure out what x cannot be. Okay. So we have x minus 2. So x minus 2 cannot equal 0. So x cannot be positive 2. And then I have an x minus 2 over here as well. So we're just going to let that go. And so then other one that we have is x plus 2 cannot equal 0. So x cannot equal negative 2. So if I get 2 or negative 2 as an answer, I can't, that's no solutions. I'm done with this problem. Okay? So, just like we did in the other one, I'm going to multiply, right? I'm going to multiply by the big denominator. You always multiply by the big denominator. I know that seems crazy, but you always multiply by the big denominator. So 2x minus 2, or times that by x plus 2, x minus 2. At least there's not as many in this one. Equals 4x over x plus 2, x minus 2. We're going to multiply that by the big denominator, x plus 2, x minus 2. Okay, and same as we did before, we're going to cancel out the things that cancel out. So x minus 2 cancels out here, and I'm left with 2 times x plus 2 equals, and then x plus 2 cancels out and x minus 2 cancels out. So I'm just left with 4x. Right? Awesome. So distribute 2 times x, 2x. 2 times 2 is 4. Sorry about that. All right. And equals 4x. And again, I do like to keep my variables positive. So I'm going to subtract the 2x, subtract the 2x, and 4 is equal to 2x. And then I'm going to divide by 2. I'm going to divide by 2. And 4 divided by 2 is 2. And can that be an answer?
No, right?
No. It says up here in orange, x cannot equal 2. So then what is my answer? It's got an answer. The only answer I got was 2, but it says x can't be 2. So
I got x equals to 2 too, but like what should be the answer then?
that's what I'm asking.
Oh,
It's got to have an answer, right? It says x is 2, but x can't be 2. So then what
Is it
would
no
my answer?
solution?
No solution. If it can't be 2, and that's the only answer I got, there's no solution to this problem. So there you go. No solution. Oopsie poopsie. Right? Just like if we would have got 0 on those first 3 problems. If we would have gotten 0, would have been no solution because x couldn't be 0, right? We said it. Denominators of fractions cannot be 0. And whatever makes them 0, if that's the only answer you got, you can't have that answer. It's no solutions. And in this case, with the blue problem, that's what I got. Up here in the orange, it says x cannot equal 2, but I got x equals 2. So no, it doesn't. All right, we get to gaslight our own problem. No, it doesn't. Right? You thought you equaled 2, but no, you don't. Okay. All right. I know we don't have a huge amount of time. We have 6 minutes. I want you to try the problem to the left. And even if you are not finished, okay, even if you're not finished with the problem on the left before 2:50, I'm going to go ahead and throw up the answer anyway at 2:49. And then at 2:50, you can come and go as you please. You can stay and ask questions. That's up to you. Okay?
Sue.
Bless you.
Thank you.
Can I say my answer?
Nobody can see your answer.
No, can I say my answer?
I haven't put the answer up yet.
Okay.
I'm waiting 2 more minutes. I can tell you if you type in the chat what you got, I can tell if you're right. Oops. Sorry, Jacqueline. Oh my goodness. See, I got in such a hurry. Uh, uh, uh. Ay, ay, ay. Sorry, when I get in a hurry, I just start making mistakes. I'm trying to get it done here. Okay, so you should have gotten 5/4. Boom, it is 250. Yes. All right, 10/8. You do want to reduce that to 5/4. Always write reduced fractions, guys. It is 1051. You could have left at 1050. You're perfectly good to go. But if anybody wants to stay and ask questions, that is up to you. Please make sure you get your homework done.